Okay, so anyway, so that was the is operator. So once again, at runtime, what will happen once this line is executed? Computer will start from S1. We'll go over here, go to the vtable pointer. Okay, we'll come over here, we'll go to the type info pointer. For this class, we'll come over here, check the name of the class, see if it matches what we said over here. If this matches over here, then it will proceed and it will create now a reference called GS, which is pointing to same place as S1, same place as S1. And then through GS, if we set the thesis, compiler will be okay with it.
Why should we use the base class reference? Because if we create the grad student object directly, then it will
Correct.
not go like.
So you know, just like when we were learning basic object-oriented programming, if we create a class, right? Let's say X, Y, Z. Okay, if we are declaring some data over here as an example, and then we are writing a get method over here and a set method over here, right?
Yeah.
Okay, remember I said people who are new to object-oriented programming always have this question, why are you writing this get and set? Won't it be easier just to make it public? And what was the answer to that?
Should be processed.
Because then anybody can change it to, you know, for example, if it's a student class, if it is a student class, right? And if this is test one, let's pretend, can somebody set it to -50?
Yes.
If we were not using get A, set A, right?
Yes.
But in these, we can write the code to check for the boundary and make sure. So this gives us proper control over it, right? So now coming to over here, your question is perfectly valid. Why even use base class reference? We won't need all of this if let's say somebody already did this grad student, S1 equal to new grad student, then you can simply say S1.thesis equal to, right? Okay, so why we have to use the base class reference? Okay, so far I haven't given you a good example where you will need it. Okay, but pretty soon I will show you many advanced situations where we need this capability. Okay. And that's why it's provided in all object-oriented programming languages. Very briefly, let me at least give you some tiny motivation for this, and you will develop it a little bit later. Okay, let's say you were creating a drawing application, you know, just like Paint in your, okay, and you wanted to be able to draw lines, you wanted to be able to draw rectangles, circles, right? Okay, can there be more than one line that we can draw? Yes. So what you will do is you will end up creating a class called line if you were to build this application yourself. Okay, and you will write a method called draw over here. Okay, and what will be the parameters of the draw? There will be a start point, end point, color, and so on, right? Or you can see put that start point, end point, color as the three fields over here. Then the draw will simply take the surface on which you wanted to draw and draw, right? So the point is you will have, okay, so you will create a class called line with some fields and some draw method, maybe some highlight method, so that if you click over here, it highlights, meaning it's being selected. Okay. Same way you will have another class called rectangle. Will it also have, for example, draw and highlight? Right? Of course, the code may be slightly different. Okay. So what do we do when we see we are repeating things? We'll create a base class called shape, right? Okay, so now suppose you wanted to, in this example, 3 and 2, 5, we have 6 objects. If somebody says file save, we wanted to save this, right? So one option is we keep checking, is this a line? Then there are 3 lines, create an array of 3 lines and save it in that array. Create a separate array of 2 circles, save it over there. On the other hand, what if we created an array of shapes and store all 6 objects and shapes? Okay, now we won't be able to do this if the base class reference cannot point to a derived class object. So like I said, as we start to do more and more advanced programming, the capabilities to use the base class becomes same way. What if you click, you wanted to highlight it? Okay, if we can write the code in our base class, no matter what shape it is, call the draw method by identifying at runtime, will make the code extremely smaller. Okay. Anyway.
But aren't we letting go of that by typecasting S1 into a grad student in this?
Correct. There is an overhead involved. Definitely, when there are extra fields involved, definitely we have to go check and then typecast it and go back to the original. Okay. But like I said, storing things in a general way, operating things in a general way, makes it easy through the base class reference. Okay, so coming back over here, that was the is operator. Now let me show you the similar code using as operator. So the code for as operator will look something like, okay, something like this. Okay, so again, pretend we've already written this S1 equal to new grad student, and we wanted to set the thesis. So we will say grad student GS equal to S1 as student. Sorry, S1 as grad student. Okay, and then if S1 not equal to null, sorry, if GS not equal to null, then GS dot thesis equal to whatever. Okay, so this is the code, typical code that we write if we are using the as operator. Okay, so let me explain what it means. Okay. This statement S1 as grad student. So again, what will it do? It will basically start with S1, go to the B table, go to the type info, and again check if the name of the class is grad student. So it does the same thing as the is operator. So this part is 100% identical. With one difference over here, if it is correct, if true, it returns a reference of type grad student. Okay, to give you an example, okay, suppose you send your friend to pick up pizza, okay? So think of it this way. You will say, go to this place and see, do they have a pizza with, let's say, mushroom topping, okay? So in this example, you'll send your friend, will go to the pizza shop, will ask them, do you have mushroom topping? Then the friend will come back, okay? Then you will say, okay, now go back and bring the pizza. So this is like going again and typecasting it to whatever you wanted, okay? So think of it this way. Here you're saying, go look for the whatever pizza you wanted and buy it and come back. Okay, so there's two possibilities. If the shop already had that pizza, you will come back with the pizza. So if true, you will get it. If not true, your friend will come back empty-handed. Okay, so in that case, the return will be null. Okay, so only if it is not null, you will do something with it. Okay, so which one is more efficient? The as is more efficient. So if you have a choice, okay, as you start doing assignments, okay, use the as operator. Okay, it is more efficient than as, but both of them do the same job. So here, there's no need for a typecasting. Okay, two possibilities: either GS will be pointing to same place as S1, if this is true, or GS will be pointing to null. So but you do have to check. If it's not null, then you proceed and set the thesis, right? Okay, so that was the second technique, as operator. So now let me give you the third technique called reflection, which will do the same thing. So in reflection, okay, in reflection, our code will again pretend we've already done student S1 equal to new grad student. So it's pointing to a grad student. So we will do over here type TP. So type is a pre-built class in .NET library. Okay, it occurs in a namespace. So if you right-click on it, you will have to resolve it. So right-click and choose resolve, and it will give you the namespace using. So automatically will give you a namespace using system.reflection. In a few minutes, if I have time, I'll go to the computer and show it to you. Okay, so anyway, you will do type TP equal to S1 dot get type. Okay, now take a look over here. What type is S1?
Student.
Or when we created the student, right? S1 is of type student. Is there a method called get type over here that we wrote?
No.
No. So where is that coming from?
Object.
Base class object, because by default it is inherited from the object. So it will be there. So what will it do? Once again, it will start from S1. We'll go to the vtable pointer, correct? We'll go to the vtable for grad student, right? Then go to the type info pointer. And this was the type info for grad student, if you recall. And it will check, get type will, basically this TP will now be pointing to this whole table, the type info table. Okay, so now we will say string, for example, nm equal to tp.name. So name is one of the properties in this type. So what will it bring back?
Name of the class.
Name of the class. Now you can say if nm equal to grad student. So it brings back as a string. So you will say nm equal to grad student. Okay, then what do you have to do? Do we still have to typecast?
No.
Can I say S1 dot thesis equal to? Okay, remember, compiler strictly goes by what is S1? Student. Does student class have a thesis in it?
No.
No, so it will not work. Okay, so you do have to. So you do have to say grad student GS equal to grad student S1, and then GS dot thesis equal to whatever. Okay, so that's the technique using reflection. So this was the technique using reflection to accomplish the same thing. Okay, so of all the three techniques, which one is better?
As.
The as operator works better, okay? But remember, the is and as operator, all they do is basically check the name of the class, okay? Whereas reflection can do a lot more things, as I will show you later on. What if you wanted to find out, is there a method over here called compute grade, okay? So then using tp.getMethods, we can find out what methods there are. We can further go check, is there a method called compute grade? So gradually I'll show you more involved things. Anyway, to summarize, the support for polymorphism in C# is provided by 3 mechanisms. And what are those 3 mechanisms?
Is,
as, reflection. So as you are programming, you should be fluent in all 3 of these. Okay, sometimes you will see people using is operator, sometimes as operator, sometimes reflection. All 3 of them can be used. However, as I showed you, the as operator is as if sending somebody to a shop and saying, you know, if you find this thing, bring it back. Okay, so that's what it does. It checks, is S1 indeed pointing to a grad student? If it is, it already brings back a reference of type grad student. So then we can easily call it after checking if it's null or not, right? Okay, so next time I'll show you on the computer all of these things, and then we'll go further to the next step.